Hi, and greetings from northern Michigan. This is Bob the Science Guy. Ever since I saw the first moon landing and the launch of Apollo 17, I've had an interest in the space program. This series is about Project Gemini. We'll go over each of the missions, profile the crews, discuss what they did and what they learned. It seems as though history has forgotten them, but they are the ones that helped get us to the moon. And the triumph of the shuttle and the ISS was built upon the foundation they carefully laid in the mid-60s. So join me now as we review the two-man cruise of Gemini, a bridge between Mercury and Apollo. Gemini 8 was one of the shorter Gemini flights at 10 hours, 41 minutes, and 26 seconds. Although it was short on duration, it was long on excitement. It was the first American spacecraft to dock with another spacecraft, the genus target vehicle, and it was also the first American spacecraft to experience an emergency in flight requiring the mission to be aborted. The pilot of Gemini 8 was David Scott, an Army graduate of West Point who elected to be commissioned in the Air Force. He trained as a fighter pilot and was stationed in Europe. In 1962, he went to the Air Force Test Pilot School under Colonel Chuck Yeager. He was the first member of Group 3, which included Buzz Aldrin, to fly in space. While his early years were spent in the Navy as a fighter pilot, Mission Commander Neil Armstrong flew as a test pilot for the X-15 program. He was selected for Astronaut Group 2 and was one of 4 members of his class selected for command on their first mission in space. Just over 6.5 hours after launch, Gemini 8 successfully docked with the genus target vehicle. 27 minutes an uncontrolled roll began. They broke away from the target vehicle, but the roll only worsened to 1 revolution a second. On the verge of blacking out, they managed to cut the reaction rockets and use the re-entry rockets to stop the roll. This maneuver severely depleted the fuel of the retro rockets, and although they had a 90-minute spacewalk planned, they were ordered home. Let's have a look at some footage from the time to see some of the highlights of the mission.
Ignition. Liftoff. Lift flight clock start. 163908. This looks good. Flight. Roger, booster. Roger, clock start. Fuel pressure running a little high. Roger. Roger, stand. How's it looking, guidance? It's looking good, flight. Roger. Go, Fido. Slightly low, no problem. Roger, Fido. How about you for staging? Thanks, we go for staging. Roger, Capcom, we're go for staging. Staging.
Now, some of you with sharp eyes may have noticed legendary Apollo flight controller Gene Kranz without his signature white vest, making his first appearance with Gemini 8. Some have asked about the cameras that catch the stage separation on the Gemini Titan. These are modified quad 50 caliber anti-aircraft guns that had the machine guns replaced with cameras. Much like the weapons, the operators aimed in on the rocket with telescopic sights and fired the film.
Roger, staging. How's our thrust look, booster? That thrust is looking a little high, flight. Roger. Okay, status check, booster. Go. Retro. Go. Fido. Go. Guidance. Guidance, you go. Stand by one, flight. Surgeon. Go. Ecom. Go. GNC. Go. How do you stand, guidance? I go, flight. Roger. Capcom, we're go. Early shutdown. We have a SECO here, flight. Roger. Shut down. Flight Fido, we had cut off. Stand by. Roger, Fido. Standing by for heavy ice. Heavy ice counting over 300 feet per second. 72 and 95. 72 is 2. Flight Fido, we're no-go. Roger. Capcom, we're no-go. Capcom, we're no-go. Roger, you are no-go. No-go.
This was not an actual Gemini mission. Nobody left the ground. Gemini did not abort. We have simply edited together an isolated launch with shots of the flight controllers simulating that launch. The flight was simulated from an adjacent room in the Mission Control Center, Houston, and like many other things in the space age, flight simulation is done by computers. The primary and backup crew for Gemini 8 will undergo 11 days of such simulated flights before launch day, March 16th. Early Early in the program, experts sit down and analyze the Gemini 8 flight. They know it is a 3-day mission. Its primary purposes include rendezvous in space with an Agena target vehicle, the first docking in space, and a 2-hour spacewalk by pilot David Scott. The experts then devise problems that could occur, some simple, some quite challenging. They feed these problems into a computer and sit back and see what happens, perhaps with a little glee. At any rate, the crew in the simulator and the controller at the console are given the problem. Both must respond correctly. About 90 problems will be run for the Gemini 8 mission. On the schedule are 2 days devoted to the Agena target vehicle, 4 days devoted to network simulations, and 2 days scheduled for running re-entry simulations, including emergency re-entries. 11 days of problem solving. Most probably none of them would turn up during the flight. But if one should, the crew and the 5,000 people in the ground network that support these 2 men would be ready. All 5 manned Gemini flights to date have been recovered as planned in the primary zone. Still, 10 more ships, 54 aircraft, and 5,000 additional men will be deployed at different stations around the world for recovery. There are 9 other planned landing areas lying within the 3 major zones of the Eastern Atlantic, the Mid-Pacific, and the Western Pacific. In the Western Pacific, the USS Leonard F. Mason, a destroyer, begins exercises on the retrieval of a boilerplate model of the Gemini spacecraft. The Mason will cover 3 landing areas within Zone 3. It will be backed up by aircraft from Okinawa and Japan. The chief difference between the primary area where the Boxer is stationed and a secondary area such as this is the comprehensiveness of coverage, the number of aircraft, ships, and recovery specialists on station. In addition, a special launch abort area covers the landmass and immediate offshore areas at Cape Kennedy. Recovery teams go out before the astronauts enter the spacecraft in case of an ejected abort from the launch pad or shortly after liftoff. There could be more extreme contingencies. The emergency might be such that a spacecraft could not land in a planned landing area. In a dire emergency, the command pilot might have to fire the retro rockets and come right down. Bare statistics come into play here. The world is 70% water and 30% land. The odds are strongly weighted toward a water landing. Aircraft are stationed at 12 points to locate the spacecraft in this emergency. Any commercial shipping in the area might then be called for assistance to pick up the astronauts. Freighters, oilers, tankers, any ship with heavy hoist equipment could also take the spacecraft aboard. If the crew comes down over land, they would use the ejection seats, leave the spacecraft, and land by parachute. Astronauts have not only a complete survival kit to sustain them, but they are trained to live off the land, even desert and jungle. Whether Gemini comes down over water or land, recovery is planned and coordinated by a NASA team of specialists. They set up the requirements for a mission and work closely with the Department of Defense. But all of this, the red telephone and the contingency aircraft off Pago Pago Island, South Pacific, seems remote on the 16th of March. The crew is entering their spacecraft for what has every sign of being a normal flight. At the same time, on Launch Complex 14, the Atlas Agena count is only 25 minutes from liftoff. The Gemini mission is largely based on a successful orbit of the target vehicle. The Agena count has no holes. Right on the nose at 10 o'clock Eastern Standard Time, the Atlas launch vehicle ignites. Atlas has 3 main propulsion engines which ignite at liftoff. 2 are booster engines and 1 is a sustainer engine. The booster engines cut off first, some 2 minutes, 40 seconds into the flight. The sustainer engine then takes over and propels the Agena to an altitude of 654,190 feet. Two small vernier engines on the Atlas continue to position the Agena properly in the later phases of launch. But as the final figures come up to the flight dynamics officer, no in-flight burns will be needed. Agena has hit the planned circular orbit of 161 nautical miles. This is a good beginning for any rendezvous flight. 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. Roger, clock, Gemini. Yes, clock running. We got a roll program. Roger, roll. Good liftoff, 8. Looking good. Our roll is in. We have a pitch program. Roger, pitch program.
The liftoff came as Flight Director Hodge had requested, 11:40 and 59 seconds. Gemini 8 goes into the clouds high above Cape Kennedy. As the spacecraft comes out of the clouds, an aerial chase plane picks it up for a close look at what it's like to ride as a spacecraft crew on top of a booster.
Mark, 50 seconds. You're looking good, 8.
After 50 seconds, the crew releases the restraints which are required for seat ejection. Gemini 8 was inserted into an orbit of 86 nautical miles by 146 nautical miles, very close to the planned values of 86 by 145 nautical miles.
Roger, we have staging, ignition. Roger, staging. Pushing. And we saw the Foley's fireball there. Yeah.
With two good orbits, target vehicle and spacecraft, Gemini 8 had a head start on rendezvous and docking. The maneuvers for rendezvous would be essentially the same as those performed by Gemini 6. So fast does the space program accelerate that rendezvous was the primary objective of Gemini 6 in December. But 3 months later, it is March, and rendezvous almost seems routine. Everyone is focused more on docking. Everyone except those who fly the mission. Then you take things step by step.
Roger, do you have solid radar lock-on with the Agena? Over.
That's affirmative. We have solid radar lock. Just a second, I'll give you our current range.
Roger, thank you. Sounds good.
We're indicating 178 miles range and elevation of about 4 degrees.
After radar lock-on, the crew will circularize their orbit inside that of the target vehicle. Zone 3 will be the planned landing zone for the next 3 revolutions, for 5, 6, and 7. After that, Gemini 8 will not be over a planned landing area again until the 10th revolution. Then it passes over the eastern Atlantic zone. If an emergency occurs in the 8th or 9th revolution, the spacecraft will land in a contingency area. Recovery is supported there by aircraft and available commercial shipping. But right now, much of this seems academic. The crew has other business.
Okay, we've got a visual on the Agena at 76 miles.
Roger, understand. Visual, Agena, 76 miles.
Hello, Houston. This is Gemini 8. We're station keeping on the Agena at about 150 feet. Way to go, partner.
You done it, boy. You done a good job.
2 to 10.
Boy, look at that sucker.
That's beautiful. See the dipole?
Do I ever? I see everything with that fella.
Man, that's great.
Man, that is really slick.
We are looking at the left or command pilot's window as the station keeping exercise with Agena begins. Gemini 8 had no difficulty in maneuvering in the vicinity of the Agena. The onboard film, as in past flights, was at 6 frames per second and is being projected at 4 times that speed. After station keeping for 35 minutes, Command Pilot Armstrong begins to move in closer to Agena, preparing his final docking approach. Both vehicles are traveling at approximately 17,500 miles per hour.
Okay, Gemini 8, we have TM solid. You're looking good on the ground. Go ahead and dock. I think we're going to hold off on this SPC thing until he does get docked. Okay, go ahead with your memory compare. Roger. Let us know what you get out of that. Flight, we are docked.
That was it. 2 vehicles docked for the first time in space. It was about this time that Jim Lovell almost qualified as the space prophet of the year. For 7 hours after liftoff and 27 minutes of normal docking, an excessive yaw and roll motion occurred. The crew punched up 400, but the trouble was not in the Agena. Unable to find an immediate answer, Mr. Armstrong undocked. The roll rate continued to build up, reaching about 1 revolution per second. Struggling to regain control, Mr. Armstrong was forced to fire the re-entry thrusters and gradually reasserted control over the spacecraft. Neither crewman experienced any loss of orientation. Gemini never approached a critical structural strain. Once the re-entry thrusters are fired, there is the possibility of fuel leakage in orbit, leaking of fuel essential for re-entry. The flight had been highly successful through 27 minutes of docking, but final action rests squarely on the shoulders of this man, the flight director. A decision came quickly. Fuel readings were too low. Abort. That was the first decision. Others follow. Weather in the Pacific. Available daylight in recovery zones. And the whereabouts of the USS Mason. A destroyer which had repetitiously practiced picking up a boilerplate model of Gemini in the waters of the Pacific came into its own. Millions of people suddenly learned that it existed. With Gemini stabilized in flight, there were several advantages to delaying re-entry for another orbit. The retrofire officer would have an exact reading on retrofire times, and the crew could prepare for re-entry, and aircraft could be on station at splashdown. This is the way it would be. The NASA coordinator leans over toward the DoD console. We want to recover in 7-3. The DoD manager immediately punches the button which puts him in contact with Pacific Recovery Control, Hawaii. Hawaii alerts the captain of the Mason. He swings around and heads for 7-3, making 30 knots. Search aircraft scramble from Okinawa. They will be over the predicted landing point 10 minutes before the spacecraft splashes down. As Gemini 8 begins its 7th and final revolution, weather is excellent in the splashdown area. The crew is busy. The command pilot has time for only this brief reflection. I'd like to argue with them about going home, but I don't know how we can. That was all. Gemini 8 sweeps past Ascension Island. Retrofire will come up over Kano, Nigeria. Air-to-ground communications are broken, but the rockets fire right on the nose. The crew begins their descent through the atmosphere. This is the view they will see for a long time, the high peaks of the Himalayas. After these forbidding mountains, the sweep of the Pacific will look friendly and hospitable. Waiting for Gemini 8 are rescue aircraft circling in the landing area, ready to pick up an electronic signal from the spacecraft. 2 aircraft from Okinawa were originally assigned here, but 5 others were quickly alerted and added to the recovery team. When Gemini 8 is only 3 miles away, a C-54 catches sight of it on the main landing parachute. After that, landing is almost routine, and Gemini 8 landed within 2 miles of the predicted impact point. The first pararescue swimmer in the water is Airman First Class Neal. Airman Neal is a veteran of combat rescue work and a good man to have on your side. He was quickly followed by 2 other rescue swimmers. It was early afternoon in the Pacific, but almost 11 o'clock at night in the Atlantic, where the USS Boxer had waited. The Mason, 3 hours away at Splashdown, reached the area at 3:17 p.m. local time. Crew and spacecraft, both in good shape, were soon aboard. Within 72 hours, NASA scientists would pin down the source of trouble. A short circuit in the wiring of the number 8 yaw thruster had caused it to fire erratically. The possibility of this failure recurring is slight, but a master switch has now been added to the Gemini spacecraft. The crew can throw this switch and cut off all power to the attitude thrusters in any future flight. Once the difficulty was corrected, we could take time out to realize that Gemini 8 had brought us closer to lunar exploration by demonstrating the first successful dock in space. Gemini 8 also gave many of us our first look at men like the 3 young rescue swimmers, Airman Neal and Moore, and Staff Sergeant Hewitt, as well as the captain and crew of the Mason.
Neil Armstrong was in the 2nd class of astronauts, the first civilian test pilot hired, and the first man on the moon. He retired from NASA and became a university professor and occasional public speaker after his landing in 1969. He never seemed comfortable with the fame that the landing brought him. David Scott remained with NASA as well. He became a command module pilot for Apollo 9 and was the command pilot for Apollo 15. Apollo 15 was a very successful mission, including finding the Genesis rock and performing the famous hammer and feather drop on the moon. Unfortunately, the mission was also stained by a postal cover scandal and the placing of an unauthorized but well-intentioned memorial on the moon to fallen astronauts and cosmonauts. Scott was denied promotion to 1-star general and retired from NASA in 1977. He is the oldest surviving Apollo commander. Well, thank you for stopping by and viewing this. I hope you enjoyed it. I enjoyed making it, and we'll finish them up here in the next few weeks. Please remember to like and subscribe to my channel. This is Bob the Science Guy. Take care.